Okay, hey guys, here's a little demo of a project that I've got in progress. What it is it's a reinforcement learning setup, and I've been working my way up to this through a series of tests that I'll probably do another video on. But um, basically, what I have is I've set up a really simple reinforcement learning environment, and it's like this. So it's, if you imagine just a line here, and on this end of the line, this is like a zero. That's zero, and on this set of the side of the line, that's one. And then imagine, I've got this point on the line, like a position, like the agent is sitting here, right in the middle of this line here. And he has a couple actions. He has three actions he can do. He can go that way, 1 unit. He can go this way, 1 unit, or he can just sort of stay in the same spot. Right. So there are his three actions. Let's call them action. That's action 0, 1, and 2. So I can take three actions. And then at the end of this process, there's a little terminal state here. Okay, this is the terminal state, and he gets one reward for getting to here. 1.0 reward, whatever. There we go. So he gets one reward here, and on the other end of this line, there's a terminal state. This is also a terminal state. Let's put that in. Okay, terminal state there. Okay, so that's his decision. And what basically happens is, if he picks this action, he goes a little bit along the line here, and then, then he picks another action, and he goes a little bit further along the line, and likewise the other way, right? Then when he hits one, that terminates, he gets one reward. If he hits this end of the line, it terminates, he gets no reward. And then if, in fact, he just takes too long, like more than 20 steps backwards and forwards, then basically, it terminates. It just terminates, and he gets no reward. So that's the environment I've built. Pretty simple environment. Very, very useful for just straight up debugging of reinforcement learning code and everything else. So what I've done, let's cut to the chase here. What I've done is we have a bunch of different experiments. So I have all these different tests here. Each of these tests is a different setup. So it's pretty much the same, running that same environment, but with a slightly different neural network. Neural networks are here on the left. So this guy is just the simple V network, and the simple V network is, I think, just a straight up matrix transform. So that's what that is. This is a matrix transform with just a little extra gain parameter here to handle variance. But essentially, all this does is takes the input, which is a number between 0 and 1, and then it puts through a linear transformation, which is basically just going to be one weight and a bias weight, and then it's going to output a value there. So we can run this guy, and I have a visualization. So let's wait for that visualization to pop. Sets up the environment, and here he is. Here he's running. Okay. So he's running here, and what you're looking at here is along this axis. This is the line 0 to 1. So where is my little diagram here? Let's bring this over so we can visualize this a little bit easier. And then Matplotlib library is going to steal the focus. That's fine. Here we go. Okay, so this 0 and 1 on this axis corresponds to 0 and 1 here. And the agent, he's going to start in the middle here, and he's going to try to figure out, do I go to nothing, or do I go towards 1 and get some reward? The blue line is the actual value function, and so this is the reinforcement algorithm's estimate, or the model's estimate of how much reward each state is worth. And these little blue dots that you're seeing flashing here, these are the actual these are the updates. So these are the updates to the TD error. Basically, each of these is the difference between the expected reward and the amount of reward you actually got is sort of the difference between these two points here. So each time you see it flash, it's sort of done one batch, and then down the bottom here you can see the reward. So you can see, he's solved this problem, he's getting reward, and that's because the value function here is pointing up in the right direction. As you would expect, let's take another look at our diagram here. Where is he? Here we go. As you would expect, the estimated value of being in state 0 should be pretty low, which is what we see. And, the estimated state of being in value 1 should be pretty high, close to 1. So one last thing is that I should mention is just down the bottom here, you can see this is the epsilon ticking over. This parameter means it's like an exploration parameter. Basically, that's the chance of just taking a random action rather than, following the action that you think is going to get the most reward, that you expect to get the most reward. So as that dives, this comes up. So this run went pretty well. I'm going to now see, maybe we can get a run that doesn't go quite so well as this. This has actually worked out really beautifully. So I'm going to stop this guy. I'm going to run this again. Let's see what happens. See if we can find one that doesn't go quite so well. This one's going to go okay, so I'm going to cancel him. Run again. What I'm looking for here is a value function, initial value function that's sort of got the wrong slope. This guy's got the right slope too. You can see he just lucked out and just happened to pick a value with a positive slope. We'll get one with a negative slope. I could hard code it, but I'm too lazy. Here we go. Here's one that started off with the wrong slope. So this is the value function here, and as you can see, again from let's bring up our little diagram here. He's pointing the wrong way. He's estimating that this guy has low value, and the terminal state, which gets us no reward, is high value. So obviously that's pretty wrong. He couldn't be more wrong. And you can see we're running into a little bit of a problem here. That he's having a bit of trouble turning this value around. So he's having trouble adjusting this value function to point in the right direction. And you can see the reason for that. If you look closely down here, you'll notice he's receiving very little reward. So he just got a little bit of reward there, and you can see it flashing up here. But the challenge he's got here is, he's just that one reward is just not enough weight compared to all these other updates which are coming here. It's just not occurring frequently enough to reverse this line. And so this guy has become stuck in a value function that is wrong. And this is the problem with a function approximation. We're not approximating a separate, each of these points all is updating the same weight, right? So we're basically integrating across this entire line all these updates. So this little guy over here, even though is not in every batch and it's just not occurring frequently enough to lift the value function in this direction versus the weight of all these. And this is the problem with using a function approximation method as simple as this to try to solve this problem. Okay, so that's that kind of sucks. So let's try something a bit more interesting. So what I'm going to do is this the guy? Yeah, this is my guy. Yeah, okay. So what I'm going to do here is I'm going to actually take all these states and I'm going to drop them into a one-hot function here. So what that's going to do is it's basically it's kind of like putting a histogram over the 0 to 1. So this is going to create 12 buckets. And it's just going to give you back a number, with a 1 in the appropriate slot. So, for example, my handy paint tool here, let's say I had the number was 0.5, okay, and I had 12 buckets in a one hot, and this is going to be, my mouse works kind of pretty shady here, but you can imagine this would be, as you can imagine 12 zeros in a row, right? 1, 2, 3, 4. We're getting there. Okay, and then I might put a 1 in this square to represent 0.5, and the rest would be 0. So that would be like a one hot representation, of the number 5, for example. And then if this was 4, I might put this guy here as 1, and so on, and 3 and 2 and 1 and 0, you know, along this line here. So that would be it. That, you know, that's the one hot. So that's basically what I'm doing here. So I'm basically taking in this number between 0 and 1, and I'm gonna drop that into a one hot anyway. And then what we're going to do up here is we're going to have what have I done here? Yeah, I'm going to have a linear. So I'm going to have a weight for each bucket. So I'm going to have 12 weights on this thick guy instead of 1, and we'll see what that looks like. So let's run this guy up. Hope this works. And boom. All right, and that's what this value function looks like. Oops, flatten that out a bit. Okay, and now you can see, you know, this value function here is a bit more flexible. Each of these areas between 0 and 1 can now sort of vary independently of each other. Okay, so now this guy here starts pulling this guy up, and this guy is able to go up because we're no longer integrating like we were in that last example over the entire line. We're just integrating, you know, over each piece. And then the way the reinforcement learning works is the updates come from adjacent states. So this is an adjacent state to this, and so when this guy goes up, he's going to pull this guy up with him. The updates will, you know, the reinforcement gradient will pull this up, not the actual gradient. And you can, you know, of the neural net, but the reinforcement learning gradient update will pull this up. And so now you can see that in fact these guys, because they can all move independently and get localized estimates at each sort of value between 0 to 1, we can now more easily move up into a value function that is better and moves us towards the right hand side where the reward is. Okay, and you notice down here it's low. So that's kind of cool. Like, you know, that was kind of interesting, but you know, I had to create that one hot here, right, in order to do that. And so I thought to myself, well, what if I could just get the network to figure that out for itself? And in fact, that's the next example. So let's take a look at that. So then what I did was I created this thing called the projection V over here. And rather than doing this one hot thing, it still takes in a single number, right? Just a single number, but it has this projection matrix. And what this guy does is it takes the single weight in and it boosts it up to a hidden size. So this would be, where to draw this, let's get a new guy up here, a new guy. So if I were to draw this, this would look like, you know, a neural network that would be like this. You know, you would have one node here, this is your one weight coming in, and then you would have a hidden layer here that goes like this, you know, with a bunch of nodes in the middle here. And I would project up into these, 4, 5, like that. And then you know, basically it's a value function, so a value function only has one output, right? And so it's going to go back like this. So this is a really simple, shallow network, but a wide, almost like a wide network, right? Oops, it's a wide kind of network. So it's taking my one input, sensor reading input here, which is a floating point number, boosting it up to a hidden layer, and then dropping it back in. So yeah, let's see what happens when we run this guy. This is him. This is the projection. So let's run this. And bam. Okay, so you can see he got the bad start with the angle sort of value function pointing in the wrong direction. Now here comes, he by chance explored and got the right update here. And we got a bit of reward coming in. It's still a very low signal. You can see down the bottom here, it's only happened once, I think. So he's only got one instance of that reward. And, you know, I don't even know if this is going to work. Let's wait and see. Alright, he still had no reward, so that update is still there though, so he's still occasionally getting that one reward update. He's getting another one. He's getting another one. You'll also notice, while this is happening, you'll notice that what tends to happen if there's no reward is the value function is going to be flattened out to 0. So because there's no reward, no state is better than any other state. And so therefore, all states, the expected reward from all states should be 0, right? And that's in fact what you see happening here. You see the value function flattening out to 0, and what we're waiting for is hopefully just a slight pull up on this end of the line. Is it going to happen? Again, there's still how many rewards? We have not seen any reward. We've only seen this one reward so far. Be nice if we got a little bit more than one reward. One of the things that is pretty important, as you kind of see in here, is that exploration is important. You're not going to be able to learn much. It is pretty surprising in this case how much you can actually get out of just one, how much mileage you can just get out of one reward here, but you know, I'm going to need to see a little bit more than just one reward point, I think, to shift this value function. And I think this guy's dead. He's not going to receive one reward's just not going to do it, unfortunately, so let's try him again. Alright, this time he got a bit of a lucky initialization, as you can see, but he's still, you know, he's just got 1 point of reward. Alright, he's got 2 rewards now. Now it's got 3, 4 rewards. And you can see that trajectory is just starting to lift a little bit here. Now it's got another 4, 5, 6 rewards, and he's basically solved this one. Here it goes. Okay. Anyway, so that's the demo. You can see now that the line's starting to come up and adjust. And if we're lucky, we may see it start to bend upwards. Obviously now there's quite a lot of reward coming in. And so this is becoming a permanent feature. It's worth mentioning also down here, this guy, what that is this is due to off-policy learning. So the exploration policy can go left or right from this state, and so it's possible from this state for you to hit the terminal state and receive 1 reward, or actually go left, but you don't actually, although you end up in this state, under reinforcement learning, off-policy learning, you actually follow the greedy policy to estimate so you estimate your value from the greedy policy. The terminal state always has 0 value, and so this ends up being 0. And here we go, and we can see here he comes up. It looks like we're just going to get a straight up linear-like behavior this time. Cool. All right. So that's the demo. Anyway, that's just a little experiment that I've been running on reinforcement learning with function approximation.